Welcome to this presentation on linked list. So I am Purnima alias Priyanka, Assistant Professor, Department of Information Technology, SRM Madurai College for Engineering and Technology. Today we will dive into the concept of linked list. So we will explore different types and understand their importance in data structures. Let's begin by understanding arrays and variables which are foundational to linked list. First of all, what is array? An array is a collection of elements, all of the same type, stored in contiguous memory locations. So what is variable? A variable, on the other hand, is a data storage location identified by a name where you can store a single value at a time. Okay. And arrays, while easy to use, have limitations like fixed size and difficulty in inserting or deleting elements efficiently. So this diagram shows the difference between array and variables. In variables, we are having different memory locations. So n0, n1, n2 are the variables holding the values at different memory locations. But in array, the variables n0 to n4 holding the values at contiguous memory locations. So what is the difference between variable and array means? So you can hold one value at a point of time, but in array we can hold many elements belong to the same data type. So we can have many different locations for variable, but in array we can have contiguous memory locations if we know the array size. But in array we cannot change the fixed size. So the next one is array-arity. Arrays are considered an abstract data type or arity, meaning they define a set of operations. So the operations that arrays support include accessing an element at a specific index, inserting and deleting elements, but these operations are inefficient when it comes to resizing or rearranging the elements. So in array-arity we can create, display, insert, append, delete, search and sort the array. So the next one is why linked list. So why do we need linked list? So the limitation of array is that they have a fixed size, meaning if we need more space, we either have to resize them, which is time consuming, or they end up with the wasted space. So in linked list, however, provide dynamic memory locations, meaning that a list can grow or shrink as needed without the overhead of resizing. So the advantages of LL over arrays are dynamic size and random access is not allowed. The next one is type of linked list. So these are all the different types of linked list. The first one is single linked list. So each node points to the next node, forming a linear structure. So that is forward navigation is allowed in single linked list. So the next one is doubly linked list. So each node points to both the next and the previous node, allowing traversal in the both directions. The next one is circular linked list. The last node points back to the first node, making the list circular. So these are all about the types of linked list. So next one is basic operations. So linked list supports several basic operations. The first one is insertion. Add a node at the beginning, end or at a specific position. So this is the insertion operation in linked list. So deletion means we remove a node from the beginning or end or at a specific position. So in traversal, we can visit each node in the list and perform an operation on it like printing the value. So this is traversal or displaying the linked list. And then in search, we can find a node based on a value or a key. Okay. And then the next one is single linked list. So a single linked list consists of nodes where each node has two parts. The first one is the data and the pointer to the next node. The last node points to null, indicating the end of the list. So at the single linked list, we are having the null node. That meaning means we are having the end of the list. So this structure allows for efficient insertion and deletions at the beginning, but is less efficient when accessing node in the middle. Okay. Let's code for creating single linked list. First we have to define a node class with two attributes. One is data and the next pointer. Then create a linked list class with methods for insertion and traversal. So struct node int info struct node star next. So next, so this is the creation for a single linked list. For display or traversing the linked list, we iterate through the node starting from the head, printing the data in each node until we reach the end, where the next pointer is null. Okay, so this is the coding for the display or traversal. The next one is doubly linked list. A doubly linked list is similar to a singly linked list, but with an extra pointer. So what this means that which points to the previous node. So this allows traversal in both directions. It's especially useful when we need to go back and forth in the list without starting over from the beginning. So to avoid to traversal from the beginning, we have to go for the doubly linked list. So it will navigate in both the directions. So next one is circular linked list. A circular linked list can be either single or double. So in this case, the last node points back to the first node instead of pointing to the null. Okay, and then this is useful for implementing circular queues or for creating data structures like the Joseph problems. Okay, so in circular linked list, we are having two types. One is single circular linked list and doubly circular linked list. So come to the conclusions. To conclude, single linked list provides a flexible and dynamic structure compared to arrays. So they allow efficient memory usage and dynamic size adjustment also. So whether it's a single or double or a circular linked list, each type serves specific use cases, and understanding them will